students, welcome to the tea processing course. I am your teacher, Yu Jun. In the previous lesson, we mainly studied the quality characteristics of green tea. Next, we will learn about the processing of pan-fired green tea. We will divide this section into two parts for your explanation. In this lesson, we will first look at the overview of pan-fired green tea, as well as the spreading and enzyme inigation processes. Overview of pan-fired green tea. Pan-fired green tea is the most widely produced and extensively manufactured type of unprocessed green tea in China. The majority of it is processed for export as meaty. Because the drying method used in processing the fresh leaves involves pan-firing, we conventionally refer to it as pan-fired green tea. Based on the differences in physical appearance, pan-fired green tea can be categorized into two types. One type, characterized by strips that are tightly twisted, is known as long pan-fired green tea. The finished product is tightly wound, slightly curved, and has a tippy, silvery appearance. Due to its resemblance to eyebrows, it is called micha. The other type, characterized by a tightly wound, round, and granular appearance, is known as round pan-fired green tea. Its finished product is called zhucha. Pan-fired green tea is produced in many regions, including Tunlu and Shulu from Anhui, Hanlu, Suilu, and Wenlu from Zhejiang, Raolu from Jiangxi, Xianglu from Hunan, Quanlu from Guizhou, Quanliv from Sichuan, and Dianliv from Yunnan. Due to differences in the quality of fresh tea leaves from different regions, variations in processing machinery and equipment, and specific processing methods, the quality of pan-fired green tea also varies. Although the quality characteristics of long pan-fired green tea differ across regions, the requirements for high-grade tea are consistent. The appearance should have tight, straight, and even strips with visible tips, no breakage, a green and glossy color, and good cleanliness. The internal quality should feature a high and lasting aroma clear and bright yellow-green liquor, a strong and refreshing taste, without bitterness or astringency, and a tender green and bright leaf base, without red stems, red leaves, scorch spots, raw greenness, or yellowed leaves. Green tea processing technology. As mentioned earlier, green tea is a non-fermented tea. Fresh tea leaves undergo spreading, enzyme importation, rolling, and drying. Let's first take a look at spreading. Spreading refers to the management of fresh tea leaves, from harvesting to enzyme importation, also known as spreading fresh leaves. The purpose of spreading fresh leaves includes three main points. First, to evaporate some moisture from the fresh leaves, reduce cell tension, and make the leaves soft, which facilitates enzyme inevasion. Second, to dissipate the grassy odor and enhance the tea aroma. Third, to promote biomechanical changes in certain chemical components, such as polyphenols and sugars, thereby improving tea quality. Next, let's explore the methods of spreading fresh leaves. First, let's look at the spreading locations and tools. If natural indoor spreading is the main method, the area should be clean, hygienic, well ventilated, and cool, avoiding direct sunlight and rain. Spreading tools generally include bamboo products, such as bamboo mats and soft trays, as well as withering troughs. The spreading thickness should generally not exceed 10 centimeters. High-grade leaves should be spread thinly, while lower-grade leaves can be spread thicker. Rain-soaked leaves or dew-covered leaves should be spread thinly, while leaves harvested on sunny days can be spread thicker. Leaves harvested in the early morning should be spread thinly, while those harvested in the afternoon can be spread thicker. During spreading, the leaves should be naturally shaken apart, not pressed by hand, and spread evenly, with uniform thickness. The spreading time generally should not exceed 10 hours, depending on leaf quality and temperature. Rain-soaked leaves or leaves processed in low temperatures require longer spreading times, while leaves harvested on sunny days or in high temperatures require shorter spreading times. Overly long spreading times can adversely affect quality. During spreading, the leaves should be turned periodically to ensure even moisture loss. Generally, they should be turned every 2 to 3 hours, with gentle movements, to avoid damaging the leaves. What is the ideal degree of spreading? The moisture content should be reduced to about 70%. The appropriate degree of spreading needs to be identified through sensory evaluation, including sight, smell, touch. Sight: the leaf color changes from bright green to dark green, and the surface gloss disappears. Smell: the grassy odor largely dissipates, replaced by a floral or fruity aroma. Touch: the leaves become relatively soft. After spreading, the next processing step is enzyme inivacation. Enzyme inivacation refers to the use of high temperatures to deactivate enzyme activity in a short time, destroying the structure and organization of fresh leaves. It is a key step in forming the quality of green tea. The purpose of enzyme inivacation includes 4 main points. First, to completely deactivate enzyme activity in fresh leaves, preventing the enzymatic oxidation of polyphenols, and achieving the desired color, aroma, and taste of green tea. Second, to dissipate the grassy odor and develop the tea aroma. Third, to alter the properties of internal components, promoting the formation of green tea quality. Fourth, to evaporate some moisture, making the leaves soft and enhancing their flexibility for shaping. The principles of enzyme integration must be followed. First, high-temperature enzyme inivacation, starting high and then lowering. The essence of enzyme inivacation is to use high temperatures to quickly destroy the catalytic function of enzymes, preserving the green quality of green tea. At the beginning, the temperature must be high to rapidly raise the leaf temperature above 80 degrees Celsius, deactivating the enzymes instantly. Later in the process, the pan temperature should be reduced. After enzyme iniquization generates a large amount of steam, the moisture in the fresh leaves cannot absorb more heat. Continuing high temperature fixation can cause excessively rapid water loss, leading to uneven deovation. Areas that lose moisture quickly are highly susceptible to scorch marks or burning as the pan temperature rises, resulting in poor quality. Second, combine tossing and covering with more tossing and less covering. During high-temperature enzyme iniquization, tossing should be used to allow the evaporated steam and grassy odor to dissipate quickly, thereby lowering the leaf temperature. The advantage of tossing is that it helps form the aroma and maintain the bright green color. However, tossing also has disadvantages, such as easily breaking buds and leaves, even scorching them, causing uneven enzyme inivacation, or resulting in red stems and leaves. The advantage of covering is that it utilizes the generated high-temperature steam to rapidly increase the temperature of the stems and veins, achieving even and thorough enzyme inivacation, thus preventing red stems and red leaves. Its disadvantage is that if covering is carried out for too long, the leaf color will turn yellow, a stuffy water odor will be produced, and quality will be affected. Therefore, combining tossing and covering can leverage the advantages and avoid the disadvantages, improving the quality of enzyme inivagination. Third, vigorous enzyme inivagation for tender leaves, gentle enzyme inimagination for mature leaves. Vigorous enzyme inimigration means appropriately more moisture loss. Tender leaves have high moisture content and strong enzyme activity, so gentle enzyme inimigration may not achieve thorough and even results, potentially leading to rotting. Moreover, the high moisture content in tender leaves is not conducive to rolling. Gentle enzyme inimigration means appropriately less moisture loss. Old leaves have low moisture content and a high degree of fiberization, so vigorous enzyme inimigration is not conducive to rolling and shaping. For high-quality tea, the fresh leaves are relatively tender and often require thorough enzyme inimitation. Next, let's look at the methods of enzyme inimitation. Enzyme inivation includes manual enzyme inivation and mechanical enzyme inivation, and the methods for both differ. Let's first look at manual enzyme inivation, tools and equipment for manual enzyme inivation. Pans, inclined pans or flat pans, accessories, winnowing baskets, soft trays, sieves, cloths, specialized tea-making oil, palm brushes, etc. Pan temperature for enzyme inimidation. The pan bottom temperature should be between 200 to 280 degrees Celsius. How to determine this? First, When the required pan temperature is reached, the pan bottom appears slightly grayish white during the day and red under dim light at night. Second, place the back of your hand 10 centimeters above the center of the pan. After about 10 seconds, there should be a distinct burning sensation. Third, toss a few buds and leaves into the pan. When a crackling sound is heard, the pan temperature has reached the desired level. If the pan temperature is too low, it may not achieve thorough and even enzyme inhibition, and can easily lead to reddening. If the pan temperature is too high, it may cause scorch points or even burnt edges, buds, or a smoky burnt odor. During enzyme inhibition, the amount of leaves added should be small rather than large, generally below 1 kilogram. Too few leaves make it difficult to operate and can easily scorch. Too many leaves cannot ensure the quality of enzyme inhibition. The enzyme inhibition time is generally about 5 minutes. If a large amount of leaves is added, the leaves are thick, or the spreading time is short, the enzyme inhibition time can be appropriately extended. Otherwise, it should be shortened. Now, let's take a look at the process of enzyme inhibition. When the pan reaches the required temperature, add the fresh leaves. Start with frequent stirring, fast at first and then slower, allowing the leaf temperature to rise quickly. Toss the leaves appropriately for about 30 seconds to 1 minute. As the leaf temperature gradually rises and a large amount of steam forms, shift from stirring to tossing to dissipate the steam. After tossing for a certain time, begin to lower the pan temperature. Stirring should be frequent, requiring fast turning, high tossing, thorough scooping, and even spreading. Ensure even and thorough enzyme inhibition with appropriate thoroughness. Once enzyme inhibition is complete, immediately remove the leaves and spread them thinly to cool quickly. Earlier, we discussed the methods and precautions for manual enzyme inhibition. Compared to manual enzyme inhibition, mechanical enzyme inhibition is much easier. Mechanical enzyme inhibition generally uses pan-type enzyme inhibition machines or drum-type enzyme inhibition machines. For example, when using a 6CST drum enzyme inhibition machine, the drum temperature should generally be above 200 degrees Celsius, and the outlet temperature should be above 85 degrees Celsius. So, what degree of enzyme inhibition meets the requirements? First, check the weight loss rate or moisture content of the enzyme inactivated leaves. A weight loss of about 40% is ideal. Second, observe the appearance of the enzyme inactivated leaves. Light. The leaf color changes from light dark green to deep dark green with a complete loss of surface gloss and no red stems or leaves. Smell. The grassy odor completely disappears, replaced by a fresh or floral fruity aroma. Touch. Stems bend but do not break. Leaves feel soft and slightly sticky. And when squeezed, they form a clump with slight elasticity. Today, we mainly covered the overview of pan-fired green tea and the 2 processing steps of spreading and enzyme inhibition. In the next lesson, we will continue to study the rolling and drawing processes of pan-fired green tea. That's all for this lesson. Goodbye, students!